students, today our topic in mathematics will be surface area and volume of a cylinder. As you know, cylinder is a three-dimensional figure with circular base and having a certain height like this bottle. It is cylindrical in shape. You can see the base of that bottle is circular with a uniform height throughout. You can see the cross section of this circular base is same, and we call that three-dimensional object as cylinder. So this is the cylinder where its top and lower base is circular in nature. This is the radius of the cylinder and that is the height of the cylinder. If we take into account only the curved surface area of the cylinder, it is equal to the curved surface area of cylinder is 2 pi r h, and if we take both its bases into account, then the cylinder will have total surface area, and total surface area of cylinder is curved surface area, that is 2 pi r h without its two bases, and we add the area of the bases that are circular in nature. The area of the circle is pi r square, and the top base has area equal to pi r square, and similarly the lower base will have the area equal to pi r square. So when curved surface area 2 pi r h and the area of both bases are added, we get, take 2 pi r as common, and within brackets will be h plus r. This is the total surface area of the cylinder. So the curved surface area of the cylinder is equal to 2 pi r h, and the total surface area of the cylinder is 2 pi r into h plus r. Now let us take some examples to find the it's required to make a closed cylindrical tank of height 1 meter and base diameter as 140 centimeter from a metal sheet. How many square meters of the sheet are required for the same? Now we need to analyze that question and understand what it says. We are going to make a closed cylindrical tank, and the metal sheet required for that, for making that cylinder, we need to find the total surface area of the cylinder. It is a closed cylindrical tank, that means the curved surfaces and the top and bottom bases are to be added, and the whole surface area of cylinder will become its total surface area. So this question is simply the question where we have to use the formula of total surface area of cylinder. Now the height of that cylinder, height of cylinder is 1 meter because diameter is given, we have to convert it into radius, and radius of cylinder is 140 centimeter. We need to bring it to radius, that is 70 centimeter. Now, one thing we have to make it clear, either to make height of the cylinder into centimeters or the radius of the cylinder, that is in centimeters, to be converted into meters. It is always very important for us to make the uniform units, so as that we can calculate its surface area or volume or total surface area, whatever. Now, if we take a look on the other part of the question, it says how many meters square of the sheet are required for making the same cylinder. That means we have to change the whatever the total surface area will be, this is to be changed into meters square. So, either you can take the whole question into centimeter square, and in the end you can convert it into meter square, or the other thing is that you can change the radius, that is in centimeters, back to meters. Now, 70 centimeter in meters can be written as 70 divided by 100, because 100 centimeter makes 1 meter, it is 7 by 10 meters. Now, therefore, total surface area of cylindrical tank of cylinder, it is 2 pi r into h plus r. 2 pi is 22 by 7, as we know, the radius is 7 by 10, into h is 1 meter and radius is again 7 by 10. 7 is to be cancelled, it becomes 44 by 10 into 1, 7 by 10 can be written as 0.7. So, 44 divided by 10 is 4.4 into 1.7. So, when we calculate 44 into 17, we get 748, take decimal up to 2 places, it will be 7.48 meters square. So, the total surface area of that cylinder is 7.48 meters square. That is, to make this type of cylindrical tank, a closed cylindrical tank, we need the metal sheet for it equal to 7.48 meters square. There is another question for you. You have to understand what sort of formula for cylinder we have to use. Now, there is the question, the diameter of a roller is 84 centimeters and its length is 120 centimeter. It takes 500 revolutions to move once over a playground. Find the area of playground in meters square. Now, we need to understand whether we have to use the curved surface area or the total surface area for that question. It says it's a roller. Now, roller is again, because it is having a diameter, a radius, so it will be cylindrical in nature. So, if we take cylinder in a sleeping position, its height will be called as its length. So there is no problem whether we write length in terms of h. And this is the radius of the cylinder. Now, when we understand this type of question, we find as if the cylinder or a roller that is of a cylindrical nature, when it rolls on the ground, it only covers the curved surface area of the cylinder. The side faces that are circular in nature does not touch the ground. So this question is purely the question of a curved surface area. So when this roller rolls on the ground, for one revolution, it will cover the area equal to its curved surface area. So when we find out the curved surface area of the cylinder, let's find out what its radius is. Its diameter is 84 centimeter divided by 2, that's 42 centimeter is the radius, and to convert it into meters we need to divide it by 100 and it gets converted into meters. Now the length of the cylinder, we can denote it by h, because when this roller will be kept in a standing position, the length will get converted into height. So nothing wrong with that if we write h for the length of the cylinder. And what is it equal to? It is 120 centimeter. So 120 centimeter is to be converted into meter, because the question says we have to find the area of the playground in meters square. So when roller rolls on the ground, only the curved surface area of the cylinder is taken into account. Find out the curved surface area of the cylinder or this roller that is cylindrical in nature. It is 2 pi RH. 2 pi is 22 by 7. R is 42 by 100. And H can be written as 12 by 10. So when we calculate this, it is 1584 by 500 meters square. So the curved surface area of the cylinder or cylindrical roller is 1584 over 500 meters square. This one curved surface area of the roller is equal to the area of the playground rolled in one revolution by that roller. So we can write one revolution of roller covers one curved surface area of that cylinder. So if the roller rolls 500 revolutions, so 500 revolutions will roll how much amount of area? It is 500 into the curved surface area of the cylinder that we got. It is 154 by 500. Now if 500 and 500 is cancelled, it is equal to 1584 meters square. So the whole playground has area equal to 1584 meters square. And I hope you understand the question, where to use the total surface area and where to use the curved surface area. Now we take another example of a pipe. A metal pipe is 77 centimeter long. The inner diameter of a cross section is 4 centimeter. The outer diameter being 4.4 centimeter. Find inner curved surface area. Outer curved surface area and the total surface area. Now, there is another type, what we call pipe. Actually, the pipe is the arrangement of two cylinders with having two different radii, but the center for both the cylinders remains the same. If we take this as a pipe, this is the internal diameter, and this is the external diameter. The internal diameter, the internal circle, and the external circle. And this happens to be the height of the pipe. So, pipe is actually the arrangement of two cylinders with some certain thickness. Now, the inner radius, the inner diameter is 4 centimeters. We can say that inner radius is 2 centimeters. And the outer radius is, which we keep as capital R, we denote it by capital R, and it is 4.4 divided by 2, that is 2.2 centimeter. And its height, the length of the pipe, is 77 centimeter. Now, the inner curved surface area of the cylinder. We will consider the inner radius with certain height as inner cylinder. So, the inner curved surface area of pipe will be 2 pi small rh, because inner radius we have denoted by small r, 2 into 22 by 7, r is 2 and h is 77. 7, 1, 7, 11, 44 into 2, 88 into 11. It's 968 centimeters square. This is the inner curved surface area of the pipe. Now, the outer curved surface area of the pipe. It's 2 pi capital RH, because the outer radius we have denoted it by capital R. So 2 pi is 22 by 7, R is 2.2 and H is 77. So 7, 1, 7, 11. And what will be the outer curved surface area? (1064.8 centimeters square) is the area, outer curved surface area of the pipe. Now, the total surface area of the pipe is something different from the total surface area of the cylinder. If you look at the top of the pipe, you will find out its top view will be like this, just the shape of a ring. The inner side will be hollow, and this shaded portion will be the surface area for the pipe. We need to find the surface area of that thickness of the pipe that we call, usually we call it a ring. This is the inner circle, inner radius, and that is the outer radius. So, to find the area of the base of the pipe, we need to find out the area between the bigger circle and the area between the smaller circle. So, the area of base of pipe is the area of bigger circle minus the area of smaller circle. And if you keep pi as common, it will be r squared minus r squared. So now let us find the area of the bases of that pipe. So area of the base of the pipe will be the difference between the larger circle and the smaller circle of the base of that pipe. Pi 22 by 7. The larger circle will have 2.2 as its radius and smaller 2. So it is 22 by 7. 4.84, 2.2 into 2.2 and 4. So it will be 22 by 7 into 0.84, that is equal to 0.12. Now 22 into 0.12, it's 2.64 centimeters square. And because this pipe will have two bases, one at the top end and another at the bottom end, so the area of both the bases will be twice 2.64. It is 5.28 centimeters square. Now the total surface area of the pipe. Is, if we look closely at the pipe, we'll see the exposed areas of the pipe are its inner curved surface area, its outer curved surface area, and the thickness of the pipe from top and bottom will be the total surface area of the pipe. So therefore, total surface area of pipe will be inner curved surface area. We found it was 968 centimeters square. Outer curved surface area, it was 1064.8 centimeters square, and the area of the both bases is 5.28 centimeters square. So to sum up all, we will get 968, 1064.8 and 5.28. It's 2038.08 centimeters square. This is the total area of that pipe. Now we are in a position to understand what a cylinder is, where we need to find the curved surface area or total surface area, and we came to know another thing about pipe, that the pipe, if we find the total surface area of the pipe, it is not the total surface area of the cylinder but something else that we discussed earlier. A cylindrical pillar is 50 centimeter in diameter. And 3.5 meter in height. Find the cost of painting the curved surface area of the pillar at rate of rupees 12.50 per meter square. Now the question says that we have a cylindrical pillar, and because when we have a pillar of a building, only its curved surface area is exposed, and it is obvious when we paint the pillar, its only curved surface area is to be taken into account. Now, the cost of painting is 12 rupees 50 paisa per meter square. That means if we find the curved surface area of the cylindrical pillar, it is to be found in terms of meter square. So, let us find out the curved surface area. Radius of cylindrical pillar it is 50 divided by 2 because diameter is twice its radius, or we can say radius is half of the diameter. When we convert it into meters, it is to be divided by 100 and it becomes 25.14, 1 by 4 meters is its radius. And the height is 3.5 meters. It's 3.5 meters. So, curved surface area of pillar, it is 2 pi RH. And H can be written as 35 by 10. So, you can do cancellations, 7, 5, 5, 1, 5, 2, 2, 1, 2, 1, 2, 2, 2, 11. So, 11 by 2 meter square is the curved surface area of the pillar. Now, this pillar is to be painted and the cost of painting per meter square is 12 rupees 50 paisa. So, cost of painting 1 meter square is 12 rupees 50 paisa, and in all we have 11 by 2, that is 5.5. We can also write it as 5.5 meters square. 11 divided by 2 is 5.5. So, cost of painting 5.5 meters square is 12.50 into 5.5. So, multiplying it will give us the total cost of painting that cylindrical pillar. So, how much is that? Let us find out. After 2 digits, we place the decimal. It is 68.75. Fine. So, this is the cost of painting that pillar. Now, we will find the volume of the cylinder. The volume of the cylinder, volume is actually the capacity. If we take that cylindrical bottle, the amount of water it can hold is its volume. So, the volume of the cylinder is equal to pi r square h. Pi r square h. If you take a deep look at the cylinder, you will find out that its base is circular in nature and the area of the circle is equal to pi r square. Now, the base of the cylinder is the area of a circle, which is equal to pi r square, and if we stack such type of circles to a certain height, it gives rise to a cylinder. So, if height is multiplied to the area of the cylinder circle, it will give you the volume of the cylinder. So volume of cylinder will be area of its base into height. Area of base is pi r square, the area of the circle, and h is the height of that cylinder. So the volume of the cylinder is equal to pi r square h. Now we take some questions from that. The diameter of a cylinder is 28 centimeter, and its height is 40 centimeter. Find the volume of the cylinder. Now the volume of the cylinder, we will find what is the radius. The radius of the cylinder is the half of its diameter, that is 14 centimeter. And the height is, the height of the cylinder is 40 centimeter. So to find the volume of the cylinder, we need to apply the formula for the volume of cylinder, that is equal to pi r square h. Now volume of cylinder is pi r square h, pi as 22 by 7, r square 14 into 14, and h is into 14. By cancelling we get 7 into 2. So 44 into 4, it is 176 into 14. It's 24640 centimeter cube, because when you find the volume, you have to take 3 dimensions into account: the length, breadth, and its height, because its cylinder, its base is 2-dimensional with the height h, and it becomes volume, that is written as raised to power 3. So the volume of that cylinder is 24,640 centimeter cube, or you can say cubic centimeter. There is an interesting question that a soft drink is available in 2 packs. One, it is having a rectangular base of length 5 centimeter, 4 centimeter, and height 15 centimeter. So we can draw this type of tin can. It is rectangular in shape. This type of tin can. We have the dimensions of that tin can are with length 5 centimeters, with width 4 centimeter, and with its height it is 15 centimeter. And we have another type of cylindrical tin can. This cylindrical tin can has the diameter of 7 centimeters and height 10 centimeter. Now we have to find out which of the 2 tin cans have greater capacity or more volume, and by how much. You can see that this type of rectangular tin can has a cuboidal shape, and to find its volume, we have already discussed that the volume of a cuboid is the product of its length, breadth and height, all the three dimensions. So volume of cuboidal tin can is the product of its three dimensions, that is length into breadth into height. That's 300 centimeter cube. And now we want to find out the volume of that cylinder. The diameter of that cylinder is 7 centimeters. We can say its radius is tin can is 7 by 2 centimeter. Its height is 10 centimeter. Therefore, its volume of the cylinder is pi r square h. R square is 7 by 2 into 7 by 2 into h is 10. It's 11 into 35, that is 385 centimeter cube. So, we clearly understood that the tin can with a cylindrical shape has more volume, although you can see the height of the cuboidal can is more than the cylindrical can. So, it is obvious the cylindrical can has more volume or more capacity than the cuboidal can. So, we can write what the question says, that cylindrical can has more volume than cuboidal volume than this cuboidal tin can by 85 centimeter cube. I hope you have understood that question, that how the question is to be done. Now we have another question of a wooden pipe, a cylindrical wooden pipe. First, let us draw the cylindrical wooden pipe. It's again the shape, it's an arrangement of basically two cylinders. With varied radii, having actually the same center. This is the wooden pipe. Now the question says, the inner diameter happens to be this, is 24 centimeters, and the outer diameter is 28 centimeters. Is this much of diameter, 28 centimeter, and the length of the pipe is 35 centimeters. This is 35 centimeter length of the pipe. You can call it the height of the pipe as well. The mass of the pipe, 1 centimeter cube, is 0.6 grams. Now, what is the mass of that whole pipe? Now, again, we mentioned what we mentioned before, that pipe is something, the arrangement of two cylinders with certain thickness, and in case of surface area, we found the total surface area of the pipe by finding its inner and outer curved surface area and the area of its bases that are exposed in terms of thickness. Now, if we want to find the volume of the pipe, we do not need to find the thickness or the areas of its spaces. It's simply the amount of material used in the pipe is the difference between the volume of its inner and the outer cylinders weight. So, how can we find the volume of the pipe? It's a simple one. Well, now, what is the inner radius? If inner diameter is 24 centimeter, then its radius will be 12 centimeter, the half of its diameter, and its outer radius will be 14 centimeter, and its length we can denote it by h and be represented as h, and is 35 centimeters. Now, the volume of the pipe will be equal to, if we directly go into the question to find the volume of pipe, we can find the difference between its outer cylinder and the inner cylinder. Volume of outer cylinder with outer radius or external radius minus volume of inner cylinder. Somewhat little bit easier than to find the total surface area of the pipe. Now, volume of outer cylinder is pi, because outer radius is denoted by capital R, it is pi r square h, minus the volume of the inner cylinder, it is again pi, but the inner radius is small r, is r square h. Now, between the two, pi and h is common, and within the brackets you can write capital R square minus small r square. Now, put values in the respective places. Pi is 22 by 7 or whatever it is given. Sometimes it is given pi, take pi as 3.14. You have to abide by what is given in the question so as to take the instruction seriously. If it is given, take pi 3.14 and you write 22 by 7, some marks can be deducted. 22 by 7, h is 35, r square, it is 14 square minus 12 square, 7175, 5 into 22, 110 into, this is a square minus b square, a plus b, 14 plus 12 is 26, and 14 minus 12 is 2. So, 110 into 52, how much is this? It's 5720. So, the volume of the pipe is 5720 centimeter cube. Now, we want to find the mass of that pipe. It is given mass of 1 centimeter cube of that wooden pipe. It's wooden pipe, so mass of 1 centimeter of cube or 1 centimeter cube of wood is 0.6 grams. The whole wooden pipe has the volume equal to 5720 centimeter cube. So the mass of 5720 centimeter of cube is equal to 5720 into 0.6. And this will give you the mass of that wooden pipe. You can write it as 572 into 6 also. It is 3,432 grams. Or in terms of kilogram, you can write 3 kilograms and 432 grams. This is the total volume, total mass of this wooden pipe with certain dimensions. Now we will find there is a relation between the surface area and the volume. Let us have one of the questions where both lateral surface area is given and we need to find the volume, or volume is given, we need to find the surface area. Let us take such type of question. If the lateral surface area of a cylinder is 94.2 centimeter square and its height is 5 centimeter, then find radius and volume. And volume, and we need to take the value of pi equal to 3.14. So in that question you find that surface area is given and the volume is to be taken out. So lateral surface area means the curved surface area. This means same. The name for lateral and curved is the same. So lateral surface area of cylinder or curved surface area of cylinder is one and the same thing. Now the lateral surface area of cylinder is 94.2 centimeters square, but lateral surface area, or you can say curved surface area of cylinder, is in terms of formula it is 2 pi RH. So we can bring an equation between the two. This is the formula of the lateral curved surface area of the cylinder and it can be matched with what it is given. It is 94.2 centimeters square. 2 as it is. In place of pi, write 3.14. The radius we do not know and is to be find out. The height is 5 centimeters and this all is equal to 94.2. So it becomes 31.4 into R is 94.2 and R is 94.2 divided by 31.4. It is 942 by 314. On cancellation it gets 3. So the radius of that cylinder is 3 centimeters. Now we can find the volume of that cylinder. Volume of cylinder, the formula for volume of cylinder is pi R square H. Pi is 3.14, R we found out is 3 to be multiplied twice by itself and H is 5. So 3.14 into 45 it is 141.3 centimeter cube. This is how we can find out volume when lateral surface area is given, or even when volume is given, we can find out the lateral surface areas.